Okay, so we're going to be using what we learned in the last lecture about resistance to solve various circuits to find total resistance. Understand we're going to be bringing current back into this, and then we're going to be introducing voltage next week, and we're going to bring in that into this. But right now we're going to kind of forget about current so much. I would say forget about it, but we're not going to be calculating anything with current. We're just going to focus on resistance. With that said, here is circuit number 1. Now, when I say that we don't have to deal with current, we're not going to put any numbers to current. We're not going to look at any of the relationships with current. But we still have to understand how charges would flow, right? So if we're looking at electrons would come out of this side of the battery. Hold on. Here we go. Electrons would come out of this side of the battery. They could flow this way to get back to the other side, or they could come out and they could flow this way to get to the other side of the battery. So we have these two different paths. Looking at this, we see everything's got to go through the 8 ohm resistor, but not everything goes through the 20 or through the 14. So this is an example of a combination circuit. And when we're solving a combination circuit, we need to look at these and we need to decide, are there any resistors in series? And if there is, we could add them together, redraw the circuit. Or are there any resistors in parallel? If there is, we could combine them into one, redraw the circuit. So the first we want to ask, is there any in series? Now we don't have to start with series. Really, when we get good at this, we just keep looking and seeing what we combine. But if we were in class right now, I would ask, are there any in series? And guaranteed a few people would give me a yes. They would say, okay, 20 and 8 are in series, because we had a definition. We said when resistors are in series, the charges that flow through the first must flow through the second. And if we look at this, the charges that flow through the 20 must flow through the 8. So that sounds good so far. But with our definition of series, there is a second part to this. We also said the charges that flow through the second must come from the first. So the charges that flow through the 8, do they have to come from the 20? No. Some of the charges that go through 8 could have come from 14. So when I say that we're not going to use current, it's kind of not true. We're not going to put any numbers to current. We're not going to make any current equations like we did in the current lecture yet. So we don't need to do that for this, but we still need to understand how charges could flow, right? So we still need to be able to visualize current. So as long as we can do that, then we know that the charges that flow through the 8 could have gone through the 21st, or it could have gone through the 14 first. So I can't say A is in series with 8 is in series with the 20 because it doesn't satisfy all the rules for series, and I cannot say that 8 is in series with 14. So I can't say there's anything in series. I can't find any two that are in series. Now, with that said, I can do this. I could say that 8 is in series with, well, I can't say it's with 20, and I can't say it's with 14, but I can say that 8 is in series with 20 plus 14, those two together. I can say that's true, the combination of the 20 and the 14. Everything that flows through the 20 and the 14 all have to go through 8, and everything that goes through 8 came from the 20 and the 14. So I could say that. It doesn't really tell us how to solve this first, but it tells us, hey, there's no two in series. So then I have to ask the question, are there any in parallel? Well, yeah, when I look at the charges that flow through the 20 ohm resistor cannot flow through the 14 because they're different paths. So the 20 and the 14, well, those two are wired up in parallel. So what I can do is I can do 1 over 20 plus 1 over 14 equals 1 over the total resistance. Let me write that out. 1 over the total resistance equals 1 over 20 plus 1 over 14. So the other thing I want to do is I want to talk about what we would be using in our calculator. So when I do this, I am looking for two buttons. I am looking for this button, maybe. If I have a TI, then it's x to the negative 1. And for me, that is in the left column, and it's 1, 2, 3, 4 down. If I'm not using a TI, it's possible that that key looks like this, right? It's kind of important. It allows us to do this calculation. So if I'm doing 1 over 20 plus 1 over 14. Then what I'm doing is I'm typing in the 20, and then I'm hitting my x to the negative 1 button. Right, so I'm hitting 20 x to the negative 1, and this replaces the 1 over, right? That's a take 20, put it under 1, and then plus, and then it's 14, and I'm hitting x to the negative 1. So we're not going to walk through this every time, but you should do this a few times to make sure you're getting the same numbers as me. So if I do this, 20 x to the negative 1 plus 14 x to the negative 1, add them up, I get 0.1214, and it keeps going. 1214, 285714. That's what I get so far. Now that's not the answer, because what is that? That is 1 over the total resistance. And 1 over total resistance equals 1 over 20 plus 1 over 14. So 1 over the total resistance equals 0.1214. And it's that big long number. Equals. There we go. So that's not what the total resistance equals. That's what 1 over the total resistance equals. We have to do this in 2 steps. Now, we're going to keep using this button. But one thing is, when we get the hang of this, we really don't have to do much on the calculator, right? So I'm going to kind of walk through the algebra. But understand, we don't need to do that much on the calculator. So 1 over total resistance equals this, but I need to solve for total resistance. So the first thing I need to do is I need to get it out from underneath the fraction. I'm going to multiply both sides by total resistance. So now they're going to cancel out on this side. So now I have 1 equals 0.1214 times total resistance. Now I'm going to divide both sides. There we go. I'm going to divide both sides by 0.1214. And again, I'm not typing anything in my calculator yet, because I'm going to do this a lot quicker on my calculator. I'm just going through the algebra. 0.1214. So those cancel out. So I get total resistance equals 1 divided by 0.1214. And again, I'm going to use the whole number, but this is fine where it is. Now, I can do all of this. I can do all of this by doing one thing. All I really need to do is hit the x to the negative 1 button, because basically I'm asking the calculator to take what I got the first calculation and put it under 1. So when I hit that and hit enter, I get 8.235. So I'm going to cut it off at 8.24. So I get 8.24. And again, with these types of calculations with ohms, I'm just tacking on the ohms at the end, which is something I don't like to do and I don't do anywhere else. But here you do, because unit analysis doesn't work with what we're talking about. So the total resistance, when I combine 20 plus 14 in parallel, or when I combine 1 over 20 plus 1 over 14, and then solve for total resistance, I get 8.24. So what do I do with that? Well, these two together combine to one resistor that's 8.24 ohms. So I'm going to take those two out, and I'm going to put one resistor in that's equal to the equivalent of these two. Now I have this circuit. And now this matches up with what I said, because I said the 8 is in series with these two. Well, these two combine to be this. So when I redraw the circuit, I have 8 plus 8.24. These two are in series. I get a total resistance of that. Next one, circuit number 2. Circuit number 2 looks like this. Again, I have to know where the battery is. I have to be able to envision current flow, but I don't need to put any numbers to current flow. Now again, I'm looking for any two resistors in series or any two resistors in parallel. Now with this one, again, there's only one place to start. I cannot find any two resistors in parallel. Some people will want to put the 20 in parallel with something. Well, what's the 20 in parallel? Well, the charges that flow through the 20 cannot flow through any of this stuff. So the 20 is in parallel with all of this. And all of this isn't in parallel with each other, so I can't really combine any of them. I can't put the 20 in parallel with the 10 because it's not. It's in parallel with the 10, the 7, the 3, the 15. It's parallel with all of them, but they're not all in parallel with each other. So that doesn't work for me. And again with the 10, well, the 10's in parallel with both of these, but they're not in parallel with each other, so I can't deal with them. But I can look at this and say, you know what? These two resistors right here are in series. The charge that flow through the 3 must flow through the 7. The charge that flow through the 7 must come up through the 3. So I can combine these two in series. And as soon as I find two I can combine in series, I'm going to combine them. I'm going to redraw the circuit. So 7 and 3 are in series, and when they're in series, you simply add them up, which means that I can take those two out and replace them with 1. That's 10 ohms. Now I look at this again. Now again, 20 is in parallel with all of these, so I still can't deal with anything like that. But this 10 is in parallel with this 10. The charges that get to here, they could either take this path to go around, or they could take this path to go around. So the charges that flow through this cannot flow through this. So these two are in parallel. 1 over 10 plus 1 over 10 equals 1 over the total resistance. We did this on the last one. I'll kind of write it out though. 1 over the total resistance equals 1 over 10 plus 1 over 10 . So again, it would be 10x. Ooh, let's get rid of that. There we go. So on my calculator, it would be 10x to the negative 1 plus 10x to the negative 1. Which is going to give me 0.2. But that's not the answer. That's what 1 over the total resistance is. So I could say 1 over the total resistance is 0.2. So now I have to do the inverse of 0.2, which works out to be 5. So when I combine these two in parallel, I get one that is 5 right here. So this one replaces those two. Or really, we could say this one replaces all the 3 of them, right? Because first I combine a 7 and a 3 into 10, and then I put 10 in parallel with 10, and I combine all that, I get 5 ohms. Now when I look at this, again, this is in parallel with these two, but they're not in parallel with each other, so I can't do much with parallel still, but I can say these two are in series. Everything that throws through the 15 can flow through the 5. Everything that flows through the 5 can come from the 15. So the next thing I would do is combine those two, and in series, nice and easy. I add them up. Those two combine to be one resistor. That's 20. Now, this is in parallel with this. And the 20 ohm resistor is basically the same as all of these. All of these 1, 2, 3, 4 combined because of the way they're wired to give me are equivalent to 120 ohm resistor like that. And now I could say the 20 is in parallel with the 20. So it's going to be 1 over total resistance. And this one I'll leave to you to do on your calculator, but it's going to equal 1 over 20 plus 1 over 20. And I can solve for this and solve for total resistance, and those two combine. And I intentionally pick numbers that are nice, easy rounded numbers or work out to be whole numbers. That's certainly not always the case, but I picked numbers intentionally this time so I don't have any decimals to deal with. But when I combine these two and solve for the total resistance, they combine to one resistor, that's 10. So again, this now replaces all of this, right? As far as the battery is concerned, as far as the charges that are going to push around are concerned, all of this can be replaced with one resistor, that's 10 ohms. Now when I look at this, I haven't even talked about this resistor yet, because if I go back, this resistor is in series with this 10 ohm, but if I go back to like the original picture, the charge that flow through the 40, where do they go? Well, they go through all this other stuff, right? So they're not in series with any one of these, right? But when I combine all that to one, well, this is in series with that. And in series, we just add them up, so I get a total resistance of 50 ohms. So we are kind of going back and forth, finding resistors in series and redrawing. or finding resistors in parallel and redrawn, and keep looking for them. Every time you find two and you can combine it, there's got to be another one somewhere that you can do this to, right? So you just keep on going until you get it down to just two resistors. Let's look at another one. I'm going to give you a moment to kind of look at it. Pause the computer if you need to. And looking at this one, start thinking about it and figuring out which ones could we combine. And here there's plenty of places to start. So the question becomes, are there any two that I combine in series? And the answer is yes. I'm going to give you a little bit to look at it. Are there any two that you can combine in parallel? So if you want to look at this stuff, pause it for a moment, take a look at it, see what you come up with. And then I'm going to go through this. All right, so there's a decent number of places I could start here. I'm going to start in, I'm going to start in one place because I got to start somewhere, but I want to say a few things about this. First of all, the charges that flow through the first must flow through the second. The charges that flow through the 8, where are they going to go next? They got to go through the 20. And the charges that go through the 20, where do they come from? They come from the 8. So I see these two are definitely in series. What else? Well, the charges that flow through this 20 must go through the 24, and the charges that go through the 24 must come from the 20. So I can combine these two in series. So I'm finding a couple things. One that's not so easy, the charges that come out, some go through this 30, they split up, they recombine, and they go through the 12. So I could say that this 30 and this 12 are in series. So again, I'm going to do this in more steps, but I'm just eyeballing and looking at it. I'm finding 3 different places where I have resistors in series. This one's a little easier to spot. This one's a little easier to spot. This one's a little harder to spot, but it's still series. Everything that goes through the 30 ends up going through the 12. Everything that goes through the 12, it all came from the 30. So what about parallel? Well, to be in parallel, charges that flow through the first must flow through the second, so that's a little harder to find. I look at these and say, okay, well, hey, these two are in parallel. Then when I think about it, you know what? It's not really just those two, though I could do those two by themselves if I wanted to, but really these 3 are in parallel. I have 1 path, 2 paths, 3 paths. The charges that flow through the 20 don't go through the 24 or 30. The charges go through the 30 don't go through the 24 or 20, and the charges go through the 24 don't go through the 20 and 30. So definitely all 3 of these are in parallel. So I got a lot of things that I could do, and I got to start somewhere, right? So, which is the first one that I decided to do? I decided to deal with these. The 24 and the 20 are in series. They combine to be one resistor. That's 44. So that was the first one that I did. Again, I had other things I could have started with, but that's the first one I did. Now, what else can I do next? Well, the next one I decided to do was these 3 in parallel. Again, I could have did 2 in parallel and then did it again, but I have 3 of these in parallel, right? This one, and this one are all in parallel with each other, even though I drew them slightly different. This is still 3 separate paths, and they still meet my conditions for parallel. So when I combine those 3 in parallel, which is going to be 1 over 24 plus 1 over 20 plus 1 over 30 equals 1 over the total resistance, you should do it on your calculator so you get the same answer as me, but what do I get? I get 8. Those 3 combine to give me 1 resistor. That's 8 ohms. So, still looking at this, again, I have multiple choices, but I'm going to do something, combine something. These are in parallel, so 1 over 44 plus 1 over 44, add them up equals 1 over the total resistance. Those two combine to be 1. I can combine those into 1 resistor. That's 22. And now I have 2 different series paths. Charges can come out of the battery, and they can go through this path. Those 3 resistors are in series. The charges can come out the battery, and they can go through these resistors. So now these 3 are in series. So I'm not saying all 6 are in series with each other, right? But I have 3 in series on one side. I have 3 in series on the other side. So I had 12, 8, and 30. If I add them up, works out to be 50. I can replace those 3 with 50, which means going back to this original one, all of this can be replaced with 1 resistor. That's 50 ohms. Now, there's reasons why we don't just replace it with 1, and we'll talk about that. But as far as the battery is concerned, that's pushing these charges around. This branch effectively has a resistance of 50 ohms. Well, now I have this side, and I know these three are in series, so I could add those up, and those can be replaced with one resistor that's 50 ohms. So now I have this. I've simplified this quite a bit. And how are these? Well, it's drawn a little different, but still, the charges that come out and go through this 50 will never go through this one. And the charges that come out and go this way and go through this 50 will never go through this one because they're different paths. So these two are in parallel with each other. So 1 over 50 plus 1 over 50 equals 1 over the total resistance. My total resistance is 25. So there is 3 circuits solved for, just using our rules for series and parallel. Take a look at them. Hopefully you try them yourself. If not, I'd go back and kind of try them through and then see how this works. And there's 3 of them that are solved.